All right, everybody, here we go again with more chemical formula knowledge and learning. So last time we looked at chemical formulas and all the crazy things we can do with chemical formulas, like the grand formula mass, like how much the thing weighs, and then we did percent composition, right? So we knew like what percentage of the mass came from which elements. And the third thing we did last time was determining the mass of an element in a sample. Remember, that was just percent composition times the sample size. Pretty easy, right? It is, well, once you know it. But we're going to keep going, but this time we're going to dig into not just the regular chemical formula, but actually the empirical formula, and this is some of the weird things that we can do. Now, the reason we do this is because this is actually pretty close to some real-life chemistry applications. Okay? So, today, we're going to play with empirical formula and like bounce back and forth, and maybe I'll do a quick empirical formula review, and hold on tight, because here we go. All right, so what we're doing today is this. We are going to go from empirical formula to molecular formula. Now, you might need to have like a quick review of what empirical formula is. So the empirical formula is the lowest ratio of the elements in a compound. For example, if we had something like, let's just do glucose, C6H12O6. This is the chemical formula, and the empirical formula is going to equal, but we got to break this down as simple as we can. We got to simplify. So if I divide everything by 6, I'll get CH2O. This is the empirical formula, the lowest ratio possible. Got it? Great. Awesome. Now, what we're going to do today is we're going to go from empirical formula, like if we're given the empirical formula, we will calculate the molecular formula, which, some people might be thinking, well, that's silly. Why would we even do something like that? Well, here's like the real reason is because when we discover new compounds, new substances, right, like new medications and whatnot, the two things that we can figure out in the lab are the molecular mass. Like we can figure out how much the molecule weighs within a range. And we can also measure the empirical formula. Like we can figure it out using the instrumentation that we have right now. But really that's it. Like we get the grand formula mass-ish, like a range, and we get the empirical formula. Those are the only two things that we can really discover in the laboratory. And so we got to work a little bit backwards to go from empirical formula and molecular mass to figure out what is the actual molecular formula. Simple, easy as pie stuff, right? So here's the process. Well, actually, before we go into the process, maybe we'll do like one or two more of these things, because I want to make something very, very, very like obvious and clear. So let's do another one. Let's do C12O3H. Well, that's a weird H. I don't know. Let's do 6. So the empirical formula, right? So we're going to divide, what's the lowest thing? We're going to divide everything by 3. So we'll have C4OH2, right? So what's important to see here is that there are, like, this is the lowest ratio, and there are multiples of the empirical formula in our molecular formula, right? So in this case, there are three empirical formulas in the molecular formula. You guys see that? You guys see how that works? So before we get going, our whole process, like what we're going to do is we're going to find out how much does this weigh, right? We're going to be given how much this weighs, and then all we do is we find out, let's just call this the molecular formula mass, and this is going to be the empirical formula mass. We're going to put the mass of the molecular formula in the numerator, and in the denominator you put the empirical formula. And this answer, right, because like let's say this is 30 and this is 10, it's going to give us an answer of 3, and that's our multiple so that's how we know how many like empirical formulas there are in the actual molecular formula itself. We'll do one or two together, and then it'll be a little bit more clear. So here's the process, my friends. One thing we got to remember is that the molecular formula is always some multiple of the empirical formula. In other words, there will always be a whole number ratio of empirical formulas that are in the molecular formula. So you can take the empirical formula and multiply it by some whole number, and that's how you'll get your molecular formula, right? And so here's how we do. The very first thing let me come over here with this thing. Sorry. Okay, so the very first thing we're going to do is we are going to calculate the mass of the empirical formula. In other words, gram formula mass of the empirical formula, right? Then what we do is we divide the empirical formula mass into molecular mass to determine what we're going to call the multiple, because that tells us how many times the empirical formula goes into the molecular. And then we multiply the empirical formula by the multiple. And what that's going to do, right? Well, actually, what we're going to do, instead of saying multiply, let's use a slightly better math term. We're going to distribute the multiple through all of the subscripts. Ooh, that was fancy. Right? So, wait, what did we have up here? So C12O3. So if we had this thing right here, C4OH2, and this was our empirical formula, right? And we found the multiple. We found through math that our multiple was 3. So what we're going to do is we will distribute that 3 throughout this empirical formula, like into the subscripts, right? So it'll be 3 times 4, 3 times 1, and 3 times 2. So that's how we will get our actual chemical formula. Does that make sense? So, quick review. You find the mass of the empirical formula. The molecular formula goes up top. The empirical formula goes in the denominator. You use multiplication, preferably a calculator, because it might be weird. And then whatever number that is, it should be a whole number. Also, it really should be a whole number, because you can't have like this can't be like 4.3 or something, right? The math should all work out really lovely here. And then whatever number that is that you get from your division, we're going to call that your multiplier. And you distribute the multiplier through all the subscripts in the empirical formula. Dig? Awesome. Here's how we're going to do this thing. So here's the question. A molecule has an empirical formula of CH2 and a molecular mass of 42. What is the molecular formula? So the first thing we're going to do is calculate the mass of our empirical formula, of this little Jim John right there. So that's how we do. So it was CH2, right? We have 1 carbon. Each carbon is 12. That way we get 12 in all. We have 2 hydrogens. Each hydrogen weighs 1. We get 2 in all. So the empirical formula has a mass of 14 AMUs. Okay, so that's the mass of the empirical formula. The second thing we're going to do is find that multiple, right? So there we go. This right here, this is the mass of the whole thing. This is the molecular mass. And this number right here, we just determined that's the empirical mass, or the mass of the empirical formula, and the mass of the molecular formula. So we're going to divide those out, and we should get a whole number, and sure enough, we get 3. That is what we call our multiple. Got it? Step 3, we're going to take that multiple, and we're going to distribute it through the subscripts, and then we'll have our final answer. So here's our empirical formula. We're going to distribute the 3 across all of our subscripts, and our final answer will be C3H6. Don't we feel like a bunch of scientific bosses right now? Lord knows I do. I'm geniusly good. You guys, we're going to own this thing, guys. All right, that's enough being silly for right now, because now here's another one that's this one. Looks actually hard, guys. I'm not gonna lie. Okay, so let's read here. Let me go over here so I can read it a little bit better. Okay, so vitamin C has an empirical formula of C3H4O3 and a molecular mass of 176. What is the molecular form? Okay, all right. So just like our other one, we've got a few things going on here. We've got the empirical formula, right? So this is the empirical formula. And we've got the molecular mass. So I'm going to write out my plan here. Because writing out a plan is usually a really good thing so we don't get lost when we're doing our math. So first thing I'm going to do is I'm going to find empirical mass. The second thing I'm going to do is find the multiple, molecular mass divided by empirical mass. And then the third thing, the easiest thing, is I'm going to distribute the multiple. All right, so let's get to it. So C3H4O3. Let's find let's find the mass of this bad boy. So for carbon, there are 3 of them. Each carbon weighs 12.0. That'll give me 36.0 AMUs from carbon. For hydrogen, there are 4 hydrogen. Each hydrogen weighs 1.0. That gives me 4.0 in all. I'm going to just assume AMU. And for oxygen, there are 3 oxygens. Each oxygen weighs, did I write that right? I did write that right. Each oxygen weighs 16.0. That's going to give me 48.0 AMUs in all. That means that the empirical formula is going to have a mass of, what is that? Did I do that right? I hope so. So we're going to call that 88 atomic mass units. That is our step 1. For step 2, we're going to find that multiple. And so that's going to be this here, the 176. That always goes up top. Because that's the mass of the whole thing, right? That's the mass of the whole molecule. And so we want to find how many empirical formulas are in there. So I'm going to take my 88 in the denominator, and we're going to math this out. I should do this for a living, guys. I was right. This equals 2. And then the third thing I'm going to do is I'm going to distribute this 2 through the empirical formula, which is C3H4O3. Right? So it's going to be 2. And now I'm going to distribute this 2 throughout the coefficients to get my final answer of C6H8O6. That's the chemical formula for vitamin C, which I hope you all are getting enough of, especially as the spring comes to a close. All right, guys, let's see what we got next. Ooh, hey, that's nice. That's it for us. That's all we got for today. So we have some practice problems. It's titled empirical formulas. We're gonna practice going from molecular formula to empirical formula, just to sharpen our skills a little bit. You know, bring it back up out of the muck. We didn't spend enough time doing it in the past, so we're gonna do it again now. So first, we're gonna find empirical formula, and then once we're really good at finding empirical formula, then we're gonna go from empirical formula to molecular formula, just like you see right over there. That's what we're going to be doing next. I hope you guys have a super awesome day. I know I'm going to have a super awesome day. And I'll see y'all, over here or maybe inside there. But I mean, whenever I see it. Have a good